Hello everyone, welcome back to the video series, revision video series or fast track series of UGC NET Electronic Science. So in this video we are going to learn about rectangular waveguide, the basics of rectangular waveguide. Okay, so only the basics we will learn in this video, and in the next video we will learn the characteristics. Okay. If you are first time to my channel, please consider subscribing. Right, so generally waveguides are classified into two types based on the shape of the waveguide. So waveguide is classified into two types. One is rectangular waveguide, okay, because it is rectangle in shape, and second is circular waveguide. So for UGC NET Electronic Science we have only rectangular waveguide. Okay, so in order to analyze this rectangular waveguide, we'll use Cartesian coordinate system or rectangular coordinate system. Okay, rectangular coordinate system or Cartesian coordinate system. Okay, so the points are x, y, z, or the axes are x, y and z respectively. Similarly, for circular waveguide we'll use circular coordinate system. Circular coordinate system or cylindrical coordinate system. Okay, so it is rho, phi and z. These are the axes. Right, so we'll see now rectangular waveguide. So this is the block diagram, or this is the basic diagram of a rectangular waveguide. Okay, so this is the rectangular waveguide. So this is A here. So generally it is represented by A, and this is B. This is B. Okay, so this is rectangular waveguide. So it will have only one conductor. So this is totally the conductor. This totally is a conductor here, made of conductor. Okay, so there will be walls around. So along this boundary, there will be walls along the waveguide. So all this boundary will have the walls. So walls are boundaries. Okay, so waveguide, what is A and B? So A is the length of rectangular waveguide. Length of rectangular waveguide. Okay, so very important, because when you are learning the characteristics of waveguide, we'll use this A and B. Okay, so here A represents the length of rectangular waveguide along x direction. And B represents height. So this is the height of rectangular waveguide. So height of rectangular waveguide along y direction. Okay, so A represents the length of the rectangular waveguide along x direction, and B represents the height of the waveguide. Okay, just remember these 2 points. So generally waveguide, the conductor, so this total waveguide consists of single conductor. It is a single conductor material. So this conductor is made of brass or aluminium or gold. Okay, so the conductor is made up of brass or aluminium or gold. So inside there is no dielectric. Any dielectric is there? No dielectric is present. So dielectric is air. Dielectric medium is air only. Okay, so conductor is made up of brass, aluminium or gold, and dielectric medium is air. Okay, so how will the EM wave travels from one end to the other end of waveguide? So through multiple reflections. So when the wave falls on this, so when the wave is traveling like this, so when wave is traveling into the rectangular waveguide, so through multiple reflections, so wave undergoes multiple reflections like this through the walls of this, so it goes multiple reflections and it reaches the other end. Okay, so due to multiple reflections it will reach from one end to other end. Okay, so due to this multiple reflections are going to be efficient, that is no losses occurs if the walls of rectangular waveguide are silver coated. If the walls are silver coated, then these reflections will be perfect without any loss and wave transmits from one place to another place with minimum losses. Okay, so the walls of rectangular waveguide must be silver coated. So conductor is made up of brass, aluminum or gold, and dielectric medium is air. All these are very important points. Okay, so due to multiple reflections occurring, so we have TE-MN mode or TM-MN mode. Okay, so M and N are half wave variations. Okay, so M and N are integers, of course. So M is equal to 0, 1, 2, so on, right? So N is equal to 0, 1, 2, so on. So both are integers, so they represents the half wave variations, so they are going to vary like this. Okay, so along X and Y directions they are going to vary, so that represents the half wave variations of electric field in TE-MN mode and magnetic field in the case of TM-MN mode. Okay, so there will be TE-MN mode and TM-MN mode in the case of waveguides. So there is no TE-M mode possible in the case of rectangular waveguide. Okay, so these are the basic points which you have to remember for rectangular waveguide. With these basic points, so if you want to learn about modes also you can learn. So when wave is traveling along plus Z direction, suppose wave is traveling along plus Z direction, I'm just revising the mode concept here. So what is TE mode, what is TM mode, and what is TM mode, everything I'll explain you with these 4 points. So when wave is traveling along plus Z direction, if Ez is equal to 0 and Hz is equal to 0, okay, like the plane wave where we have learned, so we have taken Ez is equal to 0 and Hz is equal to 0, so that mode is called as TM mode. Okay, so if wave is traveling along Z direction, if it does not have electric field and magnetic field along the direction of propagation, so that mode is called as TEM mode. Second, if the wave is having electric field Ez is equal to 0 and Hz is not equal to 0, then that type of mode is called TE mode. TE mode or H mode. Transverse electric mode or H mode. So if Ez is not equal to 0 and Hz is equal to 0, then it is called TM mode or it is called E mode. When electric field is present, then the mode is called E mode. When magnetic field is present, then it is called H mode, or reversely we'll call it as transverse electric mode, transverse magnetic mode. So fourth, if both are not equal to 0, Ez is not equal to 0 and Hz is also not equal to 0, then that type of mode is called EH mode. EH mode, or it is called hybrid mode. EH mode or hybrid mode. So in the case of rectangular waveguide, either TE mode exists or TM mode exists, and due to multiple reflections, the mode number also changes. Okay, so mode number also changes due to multiple reflections. Okay, so multiple modes exist due to multiple reflections. Okay, so these are the basic points which you have to remember for rectangular waveguide. So with these basic points, now we can go for characteristics and formula, very important formula which are asked many times in UGC NET Electronic Science exam. Okay.